In this lesson, we are going to solve equations that contain radicals or rational exponents. So let's take a look at our first example. We want to solve this equation, and we also want to be sure to check for extraneous roots. Remember that extraneous roots means that we have actually solved the equation correctly, but when we plug the values back into the equation, they don't work. So taking a look at our first example, we have 5 minus the fourth root of x equals 0. So our job is to isolate or get the root by itself. So we are going to add the fourth root of x to both sides. So we have 5 is equal to the fourth root of x. Our job now, since we have our radical isolated, is to get rid of that radical so that we have only the variable x remaining because we're solving for x. So what we want to do is we want to do the opposite operation. So if I have a fourth root, that means I want to take both sides to the fourth power. So 5 to the fourth power is 625. And a fourth root and a fourth power cancel, so that is equal to x. And the last thing we need to do is to make sure we check our answer. So we have 5 minus the fourth root of 625. 625 is a positive number. We can take the fourth root in the real number system. So we have 5 minus 5, and that is equal to 0. So that does check, and that would be the correct answer, and it would not be extraneous. Let's take a look at the next example. The first job we have is to isolate our variable. So we want to divide both sides by 3. So we have x to the 4/3 power is equal to 81. Now what we need to do is we want to get rid of our rational exponent. And to do that, we can simply multiply or raise it to the reciprocal power. So we are going to raise the other side to the reciprocal power. So remember, when you raise a power to a power, you're going to multiply the exponents together. Any number times its reciprocal is 1, so that's going to leave us with x. So what we want to do now is we want to actually take the fourth root of 81, and then we're going to take that to the third power. So if we do our factor tree without using a calculator, we can find that the fourth root of 81 is 3, and 3 to the third power is 27. So what we want to do is we want to be sure that we are doing our correct answers. So when we take the fourth root of 81, and since we're talking about our x value, this will actually be plus or minus 3 when we're solving, because when we are taking that fourth root, and basically we were taking the fourth root of the x value as well, it's just that we did that with our rational exponents. Remember, a fourth root, when we're solving an equation, any root that is even, we could have a plus or minus answer. Then when we cube that, we could actually have a plus or a minus 27. So now when we plug that back in, we find out that when we take a positive 27 and we raise that to the 4/3 power, and then we cube it, that will give us 243, as well as when we would do that with a negative 27. So this will work for both of those answers. Let's take a look at our next example. So in our next example, we want to isolate the root. So the first thing we're going to do is to add 4 to both sides. So we have the square root of 2x plus 8 is equal to 10. Now what we want to do is to get rid of that square root, so we're going to do the opposite operation, which is to square both sides. So we have 2x plus 8 is equal to 100. We're going to subtract 8 from both sides, and we have 2x is equal to 92. And when we divide by 2, we have our answer as being x is equal to 46. Now what we need to do is to check our answer to make sure that that works. So if we plug a 46 in here, 2 times 46 is 92, plus 8 is 100, and the square root of 100 is 10. So 10 minus 4 is equal to 6. So checking our answer, this works and is correct. Let's take a look at the next example. What we want to do is to isolate our root. So we want to move the negative 3 square root of 2x to the other side. So we're going to add that to both sides. And you may say, but there are two roots. That's correct, but we do want to get them by themselves. So we have 4x plus 28 is equal to 3 square roots of 2x. Now what we're going to do is to get rid of the root by squaring both sides. And when we square this side, we need to put that in parentheses so that we're squaring the whole thing. Remember, a square and a square root cancel each other. So we have 4x plus 28 is equal to 3 squared is 9. And then we have 2x when we have the root and the square cancel each other. So we have 4x plus 28 is equal to 18x. We're going to subtract 4x from both sides. So we have 28 is equal to 14x. And then we are going to divide both sides by 14. So 2 is equal to x. And what we want to do is we want to substitute that 2 back in and check to make sure that it works. So 4 times 2 is 8, and 8 plus 28 is 36. So that's the square root of 36 minus 3. And then we have 2 times 2 is 4, 3 times the square root of 4. The square root of 4 is 2, so 3 times 2 would be 6, and the square root of 36 is 6. 6 minus 6 equals 0, so that does check, and the answer will work that we found. We don't have an extraneous root yet. Let's take a look at our next example. So in this example, we have x plus 2 is equal to the square root of 2x plus 28, and we do have the root by itself. So our next job is to get rid of the root by squaring both sides. So when we square both sides, we do need to put this quantity in parentheses and square that. Now remember, when we're squaring that quantity, that means we have x plus 2 times x plus 2. We need to square that, which means both times itself. And then we get rid of the root when we have a squaring and a square root are opposite operations. So multiplying this out, we have x times x, which is x squared, x times 2, which is 2x, x times 2, which is 2x, and 2 times 2, which is 4. And now what we want to do is to combine like terms. So we have x squared plus 4x plus 4 is equal to 2x plus 28. And then we want to move the 2x and the 28 to the other side, because it would be easiest to solve by factoring if at all possible. We could use other methods such as the quadratic formula, but if we can factor, that would be much quicker for us to solve. So what two numbers can I multiply together that give me negative 24, but when I add them I get positive 2? It's going to give me a positive 6 and a negative 4. So when I set each of those equal to 0 and solve, I see that x is negative 6 and x is positive 4. So what we need to do now is to plug those back into our original equation and to see if they work. So let's try the negative 6. So I have negative 6 plus 2 equals the square root of 2 times negative 6 plus 28. So we have negative 4 equals the square root of negative 12 plus 28 would be 16. So we have negative 4, and the square root of 16 could be positive or negative 4. But if it were positive 4, that will not work because negative 4 wouldn't equal positive 4 if we use that square root. So therefore, negative 6 is an extraneous solution. Even though it works when we're solving, when we go back in and check, it does not work. let's take a look and see if the positive 4 works. So we have 4 plus 2, which is 6. And then we have the square root of 2 times 4, which is 8, plus 28 would be 36. So 6 equals the square root of 36. So 6 equals 6, which means that that one works. So the solution for this particular equation would only be x is equal to 4. Let's try one more example. So the first thing we want to do is to subtract 10 from both sides. And so we have the square root of 6x minus 5 is equal to negative 7. Now I'd like to stop right here and tell you that I already know that this is an extraneous solution. Because when I take a look in front of this radical, I see that there is no sign in front, which means I want the positive square root, the principal square root. And it's telling me that when I take the square root of this expression, I get negative 7. So already I know that this is going to be an extraneous solution, but I do want to prove it when I solve it as well. So I'm going to square both sides now that I have my radical isolated. So I have 6x minus 5 is equal to 49. And when I add 5 to both sides, I have 6x is equal to 54. And when I divide by 6, I get x is equal to 9. So if I plug that back in and I say to myself, the square root of 6 times 9 minus 5 plus 10 is equal to 3. So 6 times 9 is 54, minus 5 is 49. The square root of 49 is 7 if I'm using the positive root, and so 17 does not equal 3. So therefore, this is an extraneous solution. When you are solving square root and cube root problems, or solving radicals and rationals, we want to make sure we use opposite operations to isolate the variable. Make sure you raise each side of the equation to the same power, whether we're getting rid of the rational exponent or the root, and then be sure to check for extraneous solutions, because even though we may have solved correctly, they may not always be an answer that works.